Hello friends, in this video we will see some more basics of Etabs. In the previous video we saw how to draw a continuous beam using the ordinates as an option for defining the grids. So in this video we'll see how to use the spacing option in order to define the grids. For that we will model this truss in Etabs. Okay, so let me give you the spans that are not clear in this picture. So this first span is 5 meters, the second span is 4 meters, this is also 4 meters, and let's keep this one as 5 meters. Okay, so the height is 3 meters, right? Okay, so if this direction is your x direction, then this direction becomes your y direction, and the upward direction is the z, or you can see the g direction. Okay, so we got three point loads. So one is 10 kilonewton, the middle is 5 kilonewton, and the other one is also 10 kilonewton. Let me tell you that this tutorial is not for telling you how to design a truss. So this tutorial is simply meant for giving further introduction of Etabs. Let us now model this truss. For that you have to open a new model. Either you can go to file and click on new model, or simply you have got an option over here, just click on new model. After you have done that, use the third option, use built-in settings with. So here the options are already available. So display units, we are using metric SI, that is the length is measured in meters and the force is measured in kilonewton. If you want the length in feet, then you have to use US customary, or you can change the units that I'll show you in the later tutorials. Okay, so steel section database is Indian. It won't matter right now. So steel design code is IS 800 2007, and concrete design code is IS 456 2000. So after that, just click on OK. Now here you see a dialog box that helps you to change the grid numbers and the spacing. So we are using custom grid spacing, and specify the data for grid lines, and we'll click on edit grid data. So grid system name you can change if you want. In the previous video we used display grid data as ordinates option. So in this video we will use display grid data as spacing. Once you click here, you have to see how these numbers change. So right now grid ID a x coordinate is 0. So we know what this means. So now we'll click on this option. So the number changes to 888 and 0. So I'll explain this. Grid data as spacing means that if you see in the x direction, so we got grid line here, one grid line, and another grid line is here, another is here, and here. So the first grid is A, this is B, this is C, and this is D, right? So 8 meter means that this grid spacing is 8 meters. So you have to give 8 from A to B. So from B to C, if it is 8, then you have to give 8. So in our case it's not 8, it's actually 5. Next grid spacing is 4, and again next grid spacing is 4, and D to E it's 5, and you have to give one more spacing for this grid, that is E to E, that you have to give 0. Okay, so let's do it. So x grid spacing from A to B is 5 meters, from B to C it's 4 meters, from C to D it's 4 meters, and from D to E it's 5 meters. And let us define one more grid. So it's 5 meters, and from E to E it's 0. So you have to put this 0 value at the end. So similarly y grid data, we don't have any data in the y grid. So what we will do, we'll just select these three and we'll delete it, and we will click on OK. So after that we have to change the story data. You can simply keep this data, it won't matter how many story grid lines are presented over there. As long as we have got sufficient grid lines, it won't matter how many extra grid lines we have. For example, let me show you. In the z direction, so we need a grid line. So let me change the color. we need one grid line for this line, right? And we need another grid line at 3 meters for this line. Okay, and if we have got a grid line over here, it doesn't matter, right? So we don't have to draw anything over here. If this grid line doesn't exist, then we cannot draw this line. So we need to have sufficient grid lines. Extra grid lines, even if we have, it won't matter. So let us move on. So a number of stories, let's keep as just one. Okay, so we don't need extra grid lines, but if you have, it won't matter. So typically story height is 3 meters and bottom story height it's 3 meters. So if you want to edit the story data, you can just go to custom story data and click on edit story data. So from here also, so base is the baseline and story 1 is at 3 meters from the baseline. Okay, and we click on OK, and again we click on OK. Okay, so now this window over here shows the plan view and this window over here shows the 3D view. So here in this window we will go to the elevation, and let us close this window. So click on elevation and we'll go to elevation 1 and click on OK. Okay, so we want so we went to the elevation in this window. So again we'll click 3D here and we'll click on this window and go to elevation and click on 1 and click on OK. So this line over here is your baseline and this line over here is your story 1. This is at 0 meters and this is at 3 meters. Now what we do, we will simply draw the truss. For that we'll use this shortcut option, quick draw beams columns, and after that we'll just slide this window and left click here, again left click, again left click, again we'll left click. So after that here also left click and again left click. So after that we'll use draw beam column option again, or you can use the draw menu if you want. Okay, so left click at this point over here, so left click. After that move your mouse and left click here. Okay, again left click here. Right, so as you have already got a beam over here, now what you can do, you can just right click on your mouse. So now we can freely draw anywhere we want. So what we'll do, we'll just left click here and after that left click here and again left click here. Right, again we just right click. So after that left click here and left click here and left click here, again right click. So left click here and left click here and again right click. Now you can see that we have drawn our truss. Okay, so we'll just close this window and hit escape to escape the command. Okay, so if we see the support system, then you can see that so we don't have any support system right now. Okay, so what we'll do is let us delete these things, not from here. Okay, so we'll just delete them. And okay, so the support system over here, so we'll change the color. Okay, let's use the grid. So let's put a hinge over here, let's put a ruler over here, and let's put okay, so let's put a hinge over here also, and let's just put a ruler over here. Okay, so we'll use this support system. So what do we do? So we got hinge over here, we got hinge over here, we are fine. So we have to remove these two hinges, so we'll select them, select and again select this joint by left clicking and go to assign, and after that click on joint. So you don't have to click, you just have to hover your mouse, and after that go to restraints and over here click on this pin option and click on OK. So both the supports have been removed and we have to apply the roller here. So what we'll do, we'll just select this joint and after that go to assign, go to joint and click on restraints, and after that we select the roller option and we click on OK. Alright, so now we have applied the support system. Now we will apply load on this truss. So we got 10 kilonewton load at this joint, also 10 kilonewton load at this joint, and 5 kilonewton load at this joint. So we select this joint and also select this joint and go to assign. After that, go to joint loads and click on force. So the load pattern name is dead, and loads that can be applied is in the x direction, y direction, or the z direction. So the upward direction is the z direction, and we're applying the load in the downward direction, that is in the negative z direction. Okay, so we're applying the load of 10 kilonewton. As it is in the negative z direction, we'll apply the sign of minus. Okay, and 10 for 10 kilonewton, and we click on apply. So two loads of 10 kilonewton have been applied. After that, we select this joint by left clicking, and over here force global Z will apply the load of 5 kilonewton, and we click on apply and we click on OK. Alright, so after doing this much of work, we analyze this structure. So before analyzing the structure, let us make the weight of these members as 0. So for that, what we do, we go to define and we go to load patterns. As I have already told you, we'll see this load pattern option in detail in the coming lecture when we will model the building. So here load name is dead, so it is just a name. Okay, so name can be anything, that you have to remember. The type is the dead, so it is a dead load type, and we'll do the self weight multiplier as 0. And after that, what we do, we click on modify load and we click on OK. And after that, we analyze our structure. So either you can go to analyze and click on run analysis, or you can simply click on this option over here. So we click here and let us save the structure. So we'll do this truss analysis. So it is not a real truss analysis. Okay, so let us just save it. So you see the deformed shape in the 3D window. You just click on this window over here. After that, go to display and click on deformed shape. Here the case is dead, and just click on OK. You see the deformed shape of the truss, right? If you want to animate the structure or the deformation, click on start animation. You can see how it deflects, right? So this is just the exaggerated view, right? Okay, so stop the animation. Now after doing this much of work, we will see the axial force diagram of this structure. For that, what we do, we go to display, force stress diagrams, frame, pier, spandrel link forces, or simply click on this option over here. After that, click on axial force. The case is dead, and so we'll also check show values at controlling stations on diagram and click on OK. You can see the axial load, right? So it's minus 7.1022, and similarly other forces as well. And we know that if you want to check any specific member, you can simply left click on that member and again right click. You will get this window. You can see the value of the axial load, that is the tension. And similarly, let's just do done and yeah, doing done. Left click on this member and then right click. You can see it's the compressive force, right? Earlier it was the tension force, it is the compressive force. Okay, all right, so we know what these other things do, and let us see what happens if we do the moment diagram. Click on this option and click on moment 22, and after that, oh sorry, not moment 22, moment 33. So before that, let us see the shear and click on OK. These values are very less, 0.554. Okay, so 0.0754, they are very much low. Similarly, if we see the moment, click on moment M3, moment 33 and click on OK. The values are not very much, almost negligible. So this is how you define the grids using the spacing. So now that we have got some basic idea of Etabs and some familiarity with the Etabs, we will now model our building and we'll apply the loads and we'll do the design works. So those lectures are the core lectures of this course. Hope you will enjoy those lectures and you'll find something knowledgeable out of it.